Next up, we have Advanced Testing in Rust, and we have Tobin Harding come to speak to us today about, as you would expect from the title of the speech, some advanced techniques for testing your Rust code. Please give Tobin a warm welcome.
How's everyone doing? Good? Cool. I'm Tobin, going to talk about testing in Rust. Advanced is a bit of a subjective term. So by advanced, I mean I feel like I've advanced in the last 6 months, and I thought something was pretty cool, so hopefully you'll think so too. Can I get a show of hands? How many people write Rust for a living? Written a few projects in Rust? Cool, never heard of it. Sweet. Always wanted to do it. Always wanted to see a talk on Rust testing. Cool. No worries. If you want to look, play along, there's a repo there. I'm going to be showing a bunch of code. I'm just going to be in the editor and the terminal most of the time. So, yep. Also, it's not a formal talk. It's just like a show and tell. So if you want to know something, yell out. I can take questions anytime. If I'm wrong, feel free to stop me. I'm not a QA expert. I'm not a Rust expert. I'm just got 6 or 7 years programming professionally, and I'm just a guy who likes Rust. Cool. So I'll run quickly over unit tests and integration tests and directory structure. Then I'll talk about Rust doc examples, a couple of different ways to do mutation testing and what that is and why I think it's so exciting. We'll touch on property-based testing and why I haven't done it much. And then we'll do fuzzing and code verification. I'm a bit light on knowledge on the last 2 topics, but you know, when I wrote the submission, I was hoping to learn a bit more about it before I got here. But yeah. Cool, basic stuff. Unit test and integration test is language agnostic. Yeah, it's not all important about the layout and whatnot. There's Rust-specific ways to do it, but integration tests, the main difference is they test your API surface. Unit tests have access to your internals. So, the question that often faces me is you come to some new code, looks all right, it's got tests, they look all right, bit messy, but they're tests, right? I read through the code. Linux doesn't test, so we're right to go, right? But no. How can we check, how can we assure ourselves that we're not full of bugs and that things work? One metric is test coverage. People like to say a line of code was executed by their tests. Another way is mutation testing. So, mutation testing is, as the name suggests, mutating the code. So you have a test suite, you have software that changes a line of code, and then you run the tests. If the tests pass, then obviously you didn't test it because you just broke it and the test still passed. So it's kind of a cool concept. I never thought of it before until a few months ago and I came across it and I was like, sweet. So we have this one is cargo mutants. What cargo mutants does, this default is it just drops the body of any function or method and returns the default type for the return value. So if you're returning an int, it'll just return 0. Cool? All right. Now, I'm going to jump around. I might talk a bit fast. I get a bit excited, so if I'm going too fast or you want to know something, really stop me. This is just a wrapper type, something you do in Rust often. You wrap it into something that you want to add abstraction to. So I hacked this up. It's a bit contrived, but the aim is to show different tests, right? So we have a struct num, wraps an assigned integer. We have a constructor from a signed type. We have a constructor from an unsigned type. We have a getter, 2 signed and 2 unsigned, and then we have a more interesting method, abs, to get the absolute value. Then we have some standard Rust things. Try from is conversion functions and some error logic. Because I work on a library all day, I do all the error handling manually. And we have 2 tests for abs, a positive test case and a negative test case. Sorry, testing a positive value and a negative test value. So, looks good, right? All the non-trivial methods are tested. The one non-trivial method is tested. It's got 2 tests, so is it all right? Let's see what cargo mutants thinks. Cool, so if you remember, we replaced the return value with the default return value, as it shows there. We're going to ignore display for now, and we'll just look at, so we can see num2 signed and num2 unsigned are both not tested. And if we go to the tests, we can see that's clear, right? Cool. So we've added some stuff. Let's talk about that. Rust docs. Rust docs are specific to Rust, but I believe they're based on the Python system. They're similar to what the kernel uses now as well. They pull the documentation out of the source code. And one neat thing, I don't know too much about the others, but one neat thing is you can have code that's actually run in the examples. So you can have, and they only test the public API. They're good because they demonstrate usage and they document better. Yep. So, see now, from sign now has a bunch of stuff. The standard examples header, and then with the 3 backticks, we have code there that runs. Now this is nice because it renders. I didn't open that before. I'll just leave that. If you want to see the rendered version and I'm going too slow, we can look at that. Yeah, so you've got, when people read it in code, they can see the example. It gets rendered to HTML and all looks lovely, syntax highlighting and whatnot. And the cool thing is, we can now spell nightly correctly. So you see the top 2 are our unit tests and the next 2 are the tests we just added, the examples. And let's run cargo mutants. Awesome. So we killed 2 of the mutants. That one, like I said, we're just going to ignore for now. But we've only done 1 test and it's telling us the whole function is tested. So that's probably not true, right? We had a bug just the other day where it was a wrapper type and we had a sub function and an add function and all these things, and there was cut and paste error where the sub function called add. So like, it's a pretty embarrassing thing to merge, but this would have caught it. So it is useful. Cool, so now we have awesome docs. We've got good test coverage of the API because if anyone changes the API, the tests will fail straight away. So if you see a patch come in with changes to the examples, then you know that change it to the example code, then it's a good hint that you've changed your API, right? Cool, but is it tested sufficiently? Let's give Mutagen a go. So Mutagen is mutation testing as well, but Mutagen is a little bit more aggressive than cargo mutants. Cargo mutants, you didn't have to change the source tree, did you notice? We could just run it, we can run it on any tree and it does every method. Mutagen needs some source tree changes, but it can change a lot more things. So let's have a look at that. We've got a dependency on Mutagen coming straight from Git. We've got this line 10, got numbers? Yep, line 10, 10 and 11, we add a use statement and I use an attribute. Don't worry about that, it's not super important. It just means that I only include that line under certain conditions. And then we're mutating, as for a start, this one method. So again, the attribute's a little bit complicated, but it's not all that important. It just says to the compiler to Mutagen to mutate this. So Mutagen's going to mutate from unsigned. Let's give it a run. Cool. So it's created 3 mutants, and they've all survived. Mutagen's written by geeks, so it's all about survivors and mutants and zombies and stuff. We need to kill them. So what to do? You can see here all these numbers. The first number 51 is the line. So we can go over to 51. And it's this line, if x is less than or equal max. You can see it says what the mutant is doing, replace less than or equal with less than. So it becomes, there's only a few, it does a bunch of things. I don't know all the things it does, but a few of them often survive. And they're usually boundary cases. It changes most, and if clauses, it changes most numbers, and it's usually at the boundary that's interesting, right? So now we see already that this is pretty useful. Testing boundary cases is useful. So we have 3 on one line. we can see it's a boundary case, so of course let's check if the value is max. So we go down, so we added another test. And here we go. So we set x to max, we create a number, and then we send it to some. It round trips, so we create it with the from with the constructor, and then use the getter and assert that they're the same. So yep, that should look good. That looks good, right? Profit. Both killed except one. All right. Everyone good so far? Yep, you can read the fonts and everything's fine. Awesome. All right, so this, the next one is a little bit more curly. We've got the mutant here is replace less than or equals with greater than or equals. So that seems like it's obvious, right? But when I saw this, I was like, well, why is that even working? Of course, like it seems strange. It's not a boundary case. It seems quite wrong. And then I looked a little harder and I worked out that there was an invariant that wasn't documented. And that is that from unsigned takes an unsigned 32-bit integer, but ours is a signed 32-bit integer. So obviously there's some bits that are out of range, right? So the test that I wrote is in the documentation, so it's in examples. So we added this error section. That's like in Java where we'll put a heading errors and then everyone knows that's describing the error return. So I have described the range and then added a test that round trips to and from the constructor and the getter. This is nice because if someone comes and changes one and doesn't think to change the other, then you know, and it's like really obvious then that they're getters and setters for people new to the language. The library I work on, Rust Bitcoin, we try to do things that help people that are new to Rust because there might be hardcore engineers come in that haven't done Rust, so we try to explain things if they're a bit funny, and also we try to explain Bitcoin stuff so that people who are new to Bitcoin can learn from the code base too. So it's kind of a nice principle. All right, let's see if we killed them all. Win, all dead. So, now we have pretty good confidence in our tests, right? And here I'll segue to why I put this talk in the first place. Testing something that I always want to have done good, then it's often messy, you feel bad doing code churn, fixing people's things, and it's also sometimes boring. But there's the idea that you can read the code and know what's going on, but it's never the same as if you wrote it, right? Whereas when I was using Mutagen, I was breaking the code and then really having to look. Why did it break? So I really had to understand the algorithm. So having to write those tests was really good, and I really thought that after writing those tests, I had covered the whole thing. There's definitely could be ways you could break it that are not, like that Mutagen doesn't cover, but I felt much more confident that I'd really looked at each line. So it's pretty cool. And I was pretty confident after doing Mutagen, after doing mutation testing, that the API surface was covered, that the internals were like pretty good, and that all the boundaries were tested. But is it always correct? What's always? All right, do you have any questions on fuzzing? Oh, sorry, not on fuzzing, on mutation testing?
I'm just wondering, I saw you had the nightly flag with some of your commands and not others.
Yeah.
Do you have any comments about what features that is?
Mutagen needs nightly. I don't know exactly what what's using. I didn't look in. There's one of the dependencies requires nightly. Yeah.
Can you just repeat the question?
The question was, why did I use nightly? So that plus nightly, there's a nightly tool chain, a stable tool chain, and a bunch of old ones. And so nightly has some features. So most likely one of the dependencies uses a feature that's not in stable yet. So that's why I was using nightly.
That wasn't the question.
That was the question?
That was not the question.
Oh, sorry.
Oh, that's pretty much what I wanted to know then.
Yeah? More? Oh, cool. Does anyone want to know about the attributes? Did they look funny?
That's what I thought the question was.
That's what you wanted to know about? Okay. I've got plenty of time, so I'll show you guys that. Cool. So, CFG, and then the attribute is everything inside the brackets. and it's an all is just like a logical AND. So CFG says if test and mutate are both enabled, they exist and they're enabled, and then include the next line. Test is enabled by cargo test. These are called conditional compiler configuration options. Cargo test enables one called test. They can be any string, and I created one called mutate, and you'll see when I run it, I pass to the compiler CFG mutate. So that mutate can be anything, and that just sets the variable to true. So then that'll be included. And then CFG attribute, what it does is if the first thing is true, it changes that line to be CFG the next thing. So if test and mutate are enabled, this will change to be, this line will be changed by the compiler before code gets compiled to be CFG mutate, which tells Mutagen to mutate the method. Clear? So if you look up online how to do this, they don't do the Rust flags business. That's something that I added because I didn't want Mutagen to run anytime anyone ran the tests. I only wanted it to run in CO when I really wanted it to run. So that's why I did that. We do the same with benchmarks. It's kind of neat. Yeah, so if you look up how to run benchmarks is another nightly thing where often benchmarks use this create test and it needs nightly, and if you do what is suggested online is put a line in the code that says if you're running tests, enable this test crate, and that breaks compiling with all features. So you now cannot compile with cargo, check or build, -- all features. And I like to be able to type that because it's heaps easier when you're developing. So I came up with this trick, to add a CFG flag and use that. So, yeah. Cool. So, fuzzing, I don't know a lot about fuzzing, but what I do know is that it's taking arbitrary data and feeding it into your functions and checking that they don't explode. I don't have anything particularly good to fuzz in this code, so I added... do you want to see the last few mutations? Thought that went quick. So I added mutations to added mutagen to all the rest of the non-trivial methods, and so now we've got 13 mutants, and they're all killed bar 2. So you can see now from signs done to unsigns done and abs is done. So we've got 2 unkilled mutants at 86. All right. All on this. Self-zero just gets the inner field. So the inner field, which is the signed integer, if you remember, the signed integer is less than 0. The mutations are replacing the 0 with a 1 and the less than with less than or equal, so standard boundary cases. Can anyone see what's the problem? This if clause determines which branch to take, right? Changing less than or equal less than to less than and equal, or changing the 0 to 1 functionally just makes the 0 value take a different branch. But the 0, for the value 0, it doesn't matter which branch you take. See, 0 minus 0 is the same as 0. So I talked to the guy who wrote Mutagen, and he called this I don't care clause. I don't care statement. So the value 0, I don't care. You can branch either way. But Mutagen can't actually handle that because it can't tell what's the difference, like why you can branch on either. So an open question that you guys could help me with is I don't know how to put this information into the code, because I don't want to go and spend 2 weeks writing mutation testing, do all this stuff, and then a month later someone else comes back and they try and run it and there's 1,500 false positives. And then they've got to go through everyone and check them. That seems like a waste of time. So the best I came up with is putting a code comment, putting those lines and saying like line such and such is false positive. But that's like pretty hard to maintain. It's going to go stale pretty quickly. But I thought at least if someone's just trying to skim over it, they can go, oh, there's 2 false positives there. That's probably all right. But yeah, I'm open to tips on that one. So tests, abs handles 0. That's an obvious. Is that a boundary case when it's right in the middle? It's kind of obvious that should have been tested. And
putting a conditional compilation line that explicitly tests for zero, without when you normally compile.
so the suggestion is a conditional compilation and explicitly test for zero. I think I did try that at some stage because, so when you mutate, you test for zero, and then I believe I did try that. It's a good idea because I had it. I believe I did try it, and you get another false positive. Yeah, I think that's what happened. At the end, if we have heaps of time, I can type it up and we can see. But thanks. Any questions about those tests? Nothing crazy there. All right, let's fuzz. All right, to fuzz I added a from string implementation. So that's a trait from str that converts from a string to whatever it is you're doing, your whatever type. And that's a candidate for fuzzing. It's a bit contrived in this example, but like I said, I couldn't come up with any better. So that's the best we've got. So we take a string, and I'd like to know that you can pass any string in the whole world and my code's not going to blow up. So to do that, we create a crate called fuzz. When I was going over this talk yesterday, I realised, does everyone know about edition 2018, 2021, 2015? So every so many years, Rust puts out a new edition, and that's when they bundle up a whole heap of change, or like right now, here's a new edition, and then people can jump from one to the next. And this is cargo cult programmed from code that used edition 2015. So some of it's going to seem strange, like the fields down the bottom, but if you don't know about that, I wouldn't worry about it. If it's strange, just don't worry. So I just wrote a little script that was just going to run it for 10 seconds. Fuzzing needs to run for a lot more than 10 seconds, obviously. So it's just going to keep feeding data into this. Hongfuzz provides this macro fuzz, and that takes a closure. D's the data it's going to pass in, and it's going to call the function that I defined, doTest. Now, doTest is a little bit contrived. Here, the standard library is pretty much taking care that I don't blow up. So this is not really useful, but you could imagine a time when this would be more useful. So I convert the data to a string using from UTF-8, and then if it converts, so if that random data happened to be valid UTF-8, then we can drop in and we can try and create a string from it. This is because the from string accepts it, takes a str as argument. So I create a string, and then imagine that we've written a library and we've got another library somewhere else and we want to test our implementations against them. In this case, I'm using the stdlib, which is a bit pointless, but you get what I'm doing. So I create a string using from string radix. If that errors, I assert that our library errored as well, and if that doesn't error, I assert that we got the same thing. Now, I said I was going to mention prop testing. Prop testing is property-based testing, and the idea is that you pass random values in, and then you write a test that tests just the property, not the exact value. Property testing is a version of fuzzing, and this is like, prop testing would probably be better in this case, if you, like for all the other constructors. Where the line is between fuzzing and prop testing, I don't know exactly, and I'll explain to you why I don't use prop testing in a minute. Now we can run the fuzzer. Cool. So it's going to fuzz for 10 seconds and miraculously it's going to find no bugs. But that really hasn't given us that much more confidence, right? Yeah, we have fuzzing and we run it during the night for a set amount of time and it gives us some confidence in some cases. But we'd like something more. We want to know if it's right all the time. Code verification. So, prop testing passes some number of random variables to your method or function, but imagine if you have a function that takes two U64s. The space that you're going to test is pretty small compared to the whole thing, right? So it'd be nice if we could have some way of knowing if it's for everything. And what we can use is something called Kani. Kani's a library that does code verification. It uses magic to verify that all of any value, mathematically every line can't be reached or and can't crash. It can't handle all logic. It chokes on loops a bit. As you can imagine, the math's quite complex, and if there's like nested loops, it just takes forever to verify. So how I did it is I would add Kani tests, run it, and if they ended within like a reasonable amount of time, a minute or something, then I was like, sweet. If not, there's some things you can do. Otherwise, you have to use a different type of testing. So it's good for a subset of things that you can test. Cool. Kani's pretty easy to use. You don't even have to add a dependency because we run it with a different command. You just add this with a compiler attribute again, conditional configuration attribute, and then we have the attribute proof, which says this function's a proof. Now, similar to if you've done prop testing, so Kani any just gives me a random. It signals that this can be any value. And then I write the test. You can also limit that, so I could say any I32, and then there's a function I can call that says assume that it's less than 10 if I want to test everything less than 10. And then I just write a test, very similar to what a prop-based test would be. Sorry, very similar to what a test if I passed a value, because I know, no, it's a property, isn't it? Because we don't know the value. So we converted it, and then we just checked that it was the same. So unsigned abs is coming from the standard library. Abs is the function we wrote, and we're just comparing they're the same. So again, a little bit contrived, but we were doing this with like a hashing library, and then we use another hashing library and we check if we get the same thing. So it can be useful. Cool. So I've got one failure. That's nice. We've got 3 successes. I won't dig too much into it because like I said, I don't understand it all that much. It's got good documentation, but basically I just looked for red and then tried to work out why it was red. So if we look here, line 89, attempt to subtract with overflow. All right, so it's the same line we were looking at before. Now, it took me a fair while to work this out, and actually I had to work it out again yesterday when I was going over it, because I wrote this a few weeks ago. Can anyone see what's wrong? Attempt to subtract with overflow. The clue is our inner type is a signed integer, and we're returning an unsigned integer. How's your two's complement knowledge? So the minimum value, the minimum negative value of a type, of an unsigned, of a signed type can't fit in the unsigned type. So if it was, 2 bytes, it would be -4. 3 bytes, -4 doesn't fit into 3 bytes. 3 is the maximum value. Does that make sense? Yes. Not correct?
Well,
and let me see. So 3 bytes, if it was a 3-bit, it's a 32-bit number. If it was a 3-bit number, the minimum value would be -4. And for an unsigned, you can't have +4. So you think that's not the reason that that test is triggering? Yeah, so that's why the overflow.
the fix is to convert to sign.
The fix is...
Sorry, I can't actually see who's talking, but if you want the mic.
Oh, so what was said was the suggestion is to change, to convert to signed. If you cast a signed, then you get another warning that you're losing value, I believe. It's already signed. So yeah, we can't cast one unsigned because we don't have the value, right? So I didn't add the fix. The fix is to return an error, right? And then check the value, and if it's out of range, you have to return an error. Would that be right?
can simply check for the min value and return the unsigned corresponding value, since in this case, but the other approach involves some magic involving ignoring errors on arithmetic that has a bit stream.
So if I got you right, you're saying ignore errors.
If you negate.
Sorry, who's talking? So I can look at you. Oh yeah, yep.
The bitwise representation of your answer is the same regardless of whether it's signed or unsigned. So, in effect, if you can convince Rust to take the bits and just treat them
and just munge it,
you get the right answer.
Yeah. Awesome. Yeah, good idea. Thank you. So we saw that verification is useful. We saw that it found a bug that I wouldn't have seen. Like that, that's reasonably. I'm reasonably confident to say that I wouldn't have seen that. I wrote it and I didn't see it. I think that could have gone through review and not been seen. So is that Kani for the win? Yeah, pretty sweet, right? It is can be slow to run, and mutagen testing has a problem that I wrote like a bunch of tests, and then I looked back and I'm like, that's all super trivial. That's 2 hours of time that I don't think that really adds any value. So I don't know exactly where the line is, like how much time to spend on this. I'm still learning that. And I don't know how much time to wait for the verification. Was 1 minute too long or too short? I'm pretty impatient. And yeah, if you've got 20,000 lines of code and you start putting, you put in 100, 200 mutations. So yeah, a few open questions. So, summing up, we looked at Rust doc, we looked at examples, and we saw that the tests run those. We looked at mutation testing, basic with mutants, cargo mutants, and you didn't have to change the source tree. We looked at Mutagen, which needed source tree fixes and possibly maintenance burden. It's definitely a pain in the ass to run because you get a lot of false positives and it takes ages. Once you start putting a lot of these, it takes ages. I was trying to mess around with attributes so you could run specific bits, but I couldn't find a really nice way. In the end, I was just like using sed to change everything, change all the lines, the attributes, and then making a change in one place and then resetting the index. We've got Hongfuzz for fuzzing and Kani for verification. That's my talk. Thanks for listening. You guys want to say anything or ask any questions or give me any ideas? Mic at the back, please.
We have just about 10 minutes for questions, so I'll come around with the mic.
Thanks very much for the talk.
Thank you.
I'm a newcomer to Rust, so like my background's Java, Kotlin, Dart, and they're like the most common, I guess, rough measure of unit test is coverage. I'm just wondering, like you didn't mention that at all. Would you be able to contrast like using like code coverage versus, for instance, mutation testing? And like, do you think one's more useful than the other in terms of Rust, or like one doesn't, like code coverage doesn't make so much sense in Rust?
Sure, I can only give an opinion. It's only like totally just my personal opinion. I'm never been a QA, like employed as a QA guy. I always was suspicious of coverage because I just have to execute that line of code in a test. But like,
there's different kinds of coverage: C0, C1, C2.
Ah, cool. Okay.
There are different models of coverage. C0 coverage is did this line execute.
Yep.
C1 coverage is did you test all the branches, etc., etc. So you go to different depths of coverage,
Cool.
and test different levels of things. And a lot of people just stop at did I execute this line, but that is not the only model of coverage that exists.
Excellent. Okay, thank you. That's awesome. All right, that's something I've learned. So yeah, I can't answer if it's better, and I'm definitely going to go home and check in coverage. I always just saw the badge and was like, what does that tell me? Thank you. That's excellent. Does that fully answer your question? Cheers. Any other questions or anything else you'd like to see further? I'm about all day, so you can come up to me if you want to chat. Yeah, I literally got really excited when I was doing that mutagen stuff, looking at this algorithm, when I found a code path, false positive, and I worked out that the algorithm was correct, but it was so complex it took me like 10 minutes to work out that it was correct. And I was like, that's awesome. I wouldn't have looked at it that hard. I'd have just gone, yep, sweet, looks right. So yeah, it was really cool.
When I asked
I suggested before about conditional compilation of an explicit zero test, and you said there was an issue with another false positive.
Do you want to try it? Yep. So what was the idea? We wanted to check if the value is 0 and then do something different on 0 to 1, right? So was your idea to, when mutation is on, when mutation testing is on, to do that? Yeah? I don't actually use this form factor of keyboard at home, so there's a lot of stabbing. So that didn't work at 90. Cool, I'm happy to say this is what I did last time, and that's cool that it did do it. So now we've got the 0, 1 problem. Oh yeah, so here we can't add another line. The 0, 1 problem is a false positive you can't fix, so we replaced one false positive with another at least there. And then we've still got a problem in 94. The same problem. Oh no, we could assume that we could change the next line to remove that, and we'd get another, so we've got another false positive. We replaced one false positive with another. Do you think you could get rid of those, or are you convinced that? I didn't chase it any further than that. The question. It's not very clear why we've got the new false positive? Yeah. Oh, that's because it's this boundary case where you've got a 0, so you could change. Oh no, if that's a 1, that should be fine. Oh yeah, because 1 is 2. 0 minus 1 is 1, and 1 is 1. No. Yeah, so that's the same, right? Oh no, that's not, because it restrains 0. That is not clear why that's false positive. Oh, because we haven't written a test. So we have to add we'd have to add a test. Do you want to see me do that? Have we got time? We'd have to add the test for 1. Just be lazy, do it like this. Cool, killed. System works. So now we're left with the ones at 94, so we could probably get rid of those. So I guess then the question is, how much... the function's a lot more messy now. It's got that. Is that a net win to remove a false positive? I don't know, I tend to think that's not a net win. Yeah, I kind of feel like I don't want to come into the code base and make a bunch of changes, and then the next guy comes along and is like, wow, there's 15 lines of shit that I have to look past now just so that you could fix one small thing that probably wasn't a problem in the first place. So I'm always a bit cognizant of that. What do you older blokes reckon, that more experienced blokes? Is that true, or is it worth having all this? Probably not worth having it? Yeah. Do you have an opinion on the idea of putting the false positives in the code comment? Do you think that's worth the noise? Probably not was the comment before. Yeah. So I put it above the, like, just here, and I just wrote mutagen false positives and put a couple lines. Then I used the same form everywhere, so it was easy. Once you'd seen one, you didn't need to keep reading them.
Really, there needs to be a way of suppressing that in the test.
Suppressing, yeah. So the comment was there needs to be a way of suppressing that in the test, and I went into the repo and talked to the guy, and it shouldn't be that difficult, but I only put 2 hours work into it and I couldn't get it done in 2 hours, and he doesn't want to do it yet. So yeah, it shouldn't be that hard. You have to, it's like reasonably advanced Rust. You have to mess around with syn and proc macros and things. But yeah, once you're past Rust 101, then you can mess around with proc macros and lose a lot of days. But yeah, it would be really cool if we had that. Awesome. Thanks for your time. Thanks for coming.